Welcome to the types of chemical bonds lesson. There are three common types of chemical bonds that in chemistry we talk about: ionic, covalent, and metallic. Let's look at ionic bonds first. Ionic bonds are known as the transfer of electrons. They're basically nonmetals and metals relationship. And so they're trying to give electrons away, whether that is the metal loses electrons, while the nonmetals are gaining. The reason being is that on the nonmetals they have a minus charge, while the metals have a positive charge. And so when you're writing an ionic formula, those charges would cross. So say you have a aluminum and you have a hydroxide. So aluminum is +3 and hydroxide is -1. So you need to cross. So basically it's AlOH3. Another characteristic on ionic bonds is that it's a crystal lattice structure. So in this structure, it's basically like 3D. So inside this structure, there's like a fixed position for the bonds inside. It's like a cube, but it's like a crystal. There's like space in between. And so what that really helps us define is the fact that ionic bonds don't conduct electricity in the solid state. However, since ionic bonds are soluble, they will then be able to move freely. Well, this is electrons are able to move freely. So that means that can conduct electricity. So telltale signs that it's ionic, it's a relatively high boiling point, and it can conduct electricity in the aqueous or soluble form, but it can't conduct electricity in the solid form. So let's go back up to covalent. So covalent is the sharing of electrons. Sorry about that. Sharing of electrons. And so basically there's like a ring. Well, it's not a ring, but just to give a visual, this is where those electrons would technically share. Let me just use a different color just to make it easier. This electron will technically share, and then for this instance, maybe 2 electrons share. The thing for covalent is that they can only be nonmetals. They can only be nonmetals. And so that whether that is H2, so anything that isn't a metal can be considered a covalent bond. It doesn't have to be the same 2 elements. It can be something different. For instance, you could have NO, and this would still be considered as a covalent because they're both nonpolar. No, not nonpolar, but I mean they are nonpolar. No, not nonpolar, sorry. They are nonmetals. So, and they aren't able to conduct electricity in any form. So as we mentioned before, how ionic bonds were able to conduct electricity in the soluble form, covalent bonds, on the other hand, can't conduct electricity at all. And they're sort of weak. And so they're kind of weak, and that means it has a low boiling point / melting. Covalent bonds are also not soluble. So quite literally, you don't have to worry that much about covalent because not only are they not soluble, they have a low boiling point, they're not weak, and they're basically with nonmetals. And they don't conduct electricity. So let's go to metallic. Metallic would just kind of be your metals. And so they all conduct electricity. So you would just say conduct electricity in all forms. And so it doesn't matter in which form you could use. It's also malleable. And it has a high boiling point, melting point, so nothing super crazy about metallic. They honestly are just metals, but the key thing about metals is the sea of electrons. So that can't be confused. So the sea of electrons are able to move freely. So able to conduct electricity. So that's metallic. So let's go back and try 2 new types of bonds. So let's do network covalent. So as the name suggests, network covalent is still a covalent bond. It's just that these bonds are incredibly strong. They're way stronger than your original covalent bonds, and they sort of form this 3D sort of shape. And one of the common examples of this would be carbon. Carbon is one of the examples for a network covalent, just because of the fact that diamond is incredibly strong. But if you have a lot of carbon atoms, it's really just a covalent bond. So it's one of their stronger covalent bonds. And so they have high melting points, but they still don't conduct any electricity. No electricity. And then another example is silicon. So these are kind of the two examples that actually make sense in the real world. Silicon is also quite strong for quartz. So now the last one would be ion dipole. And so ion dipoles are basically this idea that an ion is in interaction with a polar molecule. So one of the examples can be when sodium chloride and interacts with water, for instance. So it's dissolved in water. So sodium is going to be a positive charge, and chlorine is going to be a minus charge. And hydrogen is a plus charge, and oxygen is a -2 charge. So the sodium would want to go with the oxygen because they want to balance out. They can't have both of the charges to be the same. So in that case, hydrogen goes with chlorine. One of the in real life examples are electrolytes. So they basically power the nerves and muscles based upon the ion dipole interactions. Thank you for watching this video, and I hope it has helped.